Can you guys hear? Can you guys see the full screen? I can't see the chat. Can you guys unmute and say?
Yes, sir.
Thank you. So this is the first lesson of this subject module, which is about uh, the introduction to statistical and machine learning. Before we moving on to the uh, subject about statistical and machine learning, we have to understand about what is machine learning, right? So this machine learning is actually a part of artificial intelligence, right? So in order to identify what is artificial intelligence, first we have to identify what is intelligence, right? So you might have heard about deep learning these days, right? So when you hear about the cutting edge technologies like large language models and uh, AI chatbots like ChatGPT, you hear the term deep learning, right? So deep learning is uh, a kind of machine learning uh, uh, domain, right? So in machine learning, there are different machine learning algorithms uh, b- based on different theories, right? So uh, the deep learning is one of them, where the machine learning is based on nature inspired neural networks. So first, before we learn about machine learning, so we have to learn about uh, artificial intelligence or AI. Before we move into the AI, so let's start about intelligence. So what is intelligence? In this is the most important thing, right? So you before we learn about statistical machine learning and all these mathematical stuff or statistical stuff, we have to understand what we are going to achieve with this statistical and machine learning, basically machine learning, right? So in order to do that, we have to identify what is intelligence. So who have intelligence in this world or the universe? Hmm? Who has the intelligence? Uh, Living beings, humans, or anything else? Mm, we can say like these questions are actually in the still in the philosophical domain. With they are not 100% answered because these are not exactly answerable with exact answers. But when it comes to intelligence, we have a specific a kind of highly reliable answer. Right? So the intelligence is something the advanced, not advanced, but some form of living beings have. Right. So why do living beings have intelligence? Why other natural stuff don't have intelligence? Have you thought about that? Do amoebas and other uh, small scale organisms have intelligence? Are only the advanced living beings like dogs and elephants and humans have intelligence? Hmm? What do you think? So, before going into that, we have to identify again what is a living organism, right? So this is not actually going beyond our scope of statistical and machine learning, but in order for you to understand the fundamentals of this intelligence, we have to dive that into dive deeper into that direction. Not that much, but what is a living being, right? So in all the non-living beings, that means most of the living beings, right? So most of them are built using DNAs, right? So DNAs or RNAs, which is a sequence of base pairs, like chemical base pairs, right? So if you don't know much about biochemistry or those things, that's fine. So, but just I am going to give you a basic understanding why the intelligence is only there in living organisms, right? So when it comes to a living organism, if you can see it today, right? So if you can observe it in the environment, that means that particular living organism, that means it can be a advanced organism like mammals, like humans and dogs, or some very primitive living organism like amoebas or bacteria, right? Those organisms are there because they could reproduce, right? Before reproduce, they have to live, right? So in order to live, they have to uh, eat food and do and make energy out of the food, right? So they have to breathe and then they have to eat, then they have to move, or they have to uh, save themselves from the external environment, like the sun itself or the water, and get eaten by other animals or other living organisms. If they could have gone through all those environmental uh, attacks or environmental issues, only then they could have saved in our world, right? So otherwise they would have wiped out from the earth, as we know, up to now, right? So we say that only the life is there on earth, right? So for now, just think like that, right? So if that is the case, so they are because they could have uh, reproduced. That means they could make replicas of their DNAs, right, or RNAs without uh, getting eaten by other living organisms, or without getting destroyed with natural disasters like flooding, or getting dried out with sunshine, right? Or get crushed out with stones or storm well, like or all the other environmental factors, right? So they could have saved from the environment and their predators, the living organisms that are going to eat them, right, for their survival. And then they could have take food out from the environment, and then they could have reproduced. That means they could have uh, copied their DNAs, basically, right? That is the idea of reproduction, right? They could have reproduced their DNAs or their RNAs, so that they could survive in this world, right? So in order to do that, they should have some predictive power, right? So about the environment, so that then they can take actions, and they can take precautions to save them from getting killed, and find the food and how to reproduce. In order to take all these decisions, they had some higher decision making power than the other objects in the natural world, like if you take something like a rock or a mountain or something like that, or some, I would say, a river, or whatever that is there in the natural world, right? So other than those things, a living organism, it may be a tree, or it may be a uh, other bacteria, or a mammal, those things could have saved in the environment because uh, they could predict the environment, and they could take actions to for their own benefit, right? Actually, that is the intelligence. So when they were getting uh, evolved from basic formats like bacteria. Some say it's viruses are also living organisms. Some say it's half living organisms, whatever it is, right? So bacteria are kind of living organisms, and there are trees or plants, and there are animals, and all those things are have some form of life, right? So they are there because they can reproduce and they can replicate their source code, right? Source code means their DNA or the RNA, so that they can copy them again and again by extracting chemicals from the environment like carbon dioxide and water when it comes to plant, or eating the other plants where the animals, what the animals do, right? And then they can replicate their DNA or RNAs. So in order to take these decisions, they use intelligence, right? So then they have evolved from primitive formats to advanced creatures like mammals and humans, where they had larger brains and advanced cognitive systems than the previous forms like amoebas and bacteria. Now we have this level of intelligence. So once we have come up to this level, where we have computers and other intelligence formats, uh, we have come to a state that we want an automated intelligence without using our own intrinsic human intelligence. Why can't we make the intelligence artificial, right? So when it comes to intelligence, it is all about making decisions, right? So in this intelligent domain, we can't in the earlier times, people were arguing what is the level of uh, decision making power, where we have to say where it is, where the system or a person or the AI is intelligent. So now the idea is that because we couldn't find any line that separates from the basic decision making power and the advanced human like intelligence or something, because it is a kind of continuous form of intelligence or decision making power, which are based on basically the statistics as we know, right? So that's how we that are those are the principles, those are the assumptions that we make when we are developing this artificial intelligence module, right? So what we realized was that even the smallest decision making thing, decision making entity has some sort of intelligence, right? So when it comes to a thermostat, right? So you might have not seen it, right? So when it comes to a thermostat in an air conditioner, uh, you can see when the so not in these days there are uh, not thermostat based systems called inverter ACs, not about those air conditioners. The old form of ACs, we had switches called thermostats, where when the temperature goes down, it shuts down and it lets the temperature to go up. And when the temperature is higher than a certain level, the thermostat turns on and the air conditioner starts to cool down. Right? It is there in all most of it was there in most of the uh, electric ovens, electric cookers, and rice cookers, and all those things. Right? So in the last couple of decades, right? So in the thermostat, what it does is, so depending on the temperature, it can uh, turn on or and on a particular switch. So it is actually, so this may sounds sarcastic, right? So it is also a form of artificial intelligence, right? So that means because it is artificial, because it was created by humans. Why it is intelligent? Because it can make one bit predictions whether it is on or off based on the information that are taken from the environment, right? So the thermostat is the simplest example that we can give for an AI system, right? So this is not one of my finding. This was said by serious AI researchers, right? So this concept of lowest level of AI or the artificial intelligence, which they have compared, they have given the example of this thermostat, right? So the idea is that we are not going to learn about thermostats, right? Because we don't have to learn about those things because we have done much uh, uh, advanced AI using algorithms, right? So if you write a program or some source code, what we are doing is actually we are writing some AI code because we have some logic, and when the inputs are matching to these logics, we are processing the data. So that is also a form of AI. So the scope of AI is very large, right? So now you can see, right? So from thermostat to a very complex logic, everything is AI, right? So in the earlier time of AI, it was based on expert systems. So the expert systems were the systems that are defined by that are developed by experts, right? For example, if you want to diagnose a certain disease or something, right? Uh, the experts in this medical field, so they would define those expert system based on programming logic, where if you have these symptoms, for example, if you have cold greater than 100, and if you have like blood pressure less higher than this level, then you would have this one, and so on and so on. You can write some hard code logic, right? And then you can make a system that can be developed with the help of experts, so that the expert system can be later used with new data, where the expert system can uh, independently make decisions without the help of the original experts, right? So that means we can make computerized systems using programming logic, so that it can make decisions. So not only these kind of expert systems, now there are like in order to control the mechanical parts, there's a theory, there's a mathematics based theory called control theory. So that is also a form of artificial intelligence. So, and when you are going to process, no, when we are going to process data and find optimum paths in algorithms, if you are much familiar with computers, uh, in algorithms, writing algorithms is also a form of artificial intelligence. And if you are finding paths or finding the optimum uh, uh, logic, if you are finding in a graph, so the graph path searching is also a form of artificial intelligence. So all of these stuff that are depending on the hard coded logic and so on, those are artificial intelligence. But there is another form of artificial intelligence that were evolving, which is known as machine learning. Right? So in the machine learning, the basic difference is that we don't get the help from experts, so we don't have any idea about the nature of the problem that we have in our hand. Like in order to, for example, if you want to diagnose a certain patient based on their symptoms, we don't have the expert opinion. Like if you want to diagnose a dengue patient, they should have this much of fever and this much of uh, blood pressure or the platelet count reduction when it comes to a certain disease, right? So you don't have any need for any experts. But when you give a lot of information that where we think that may be relevant to this disease, like we give all the information like the platelet count, blood pressure, red blood cell count, and oxygen, blood saturated oxygen level, the age and the temperature, uh, on all those things, and then we give there are we give a lot of labeled data and then we ask the computer or the algorithm to decide uh, to learn whether how to decide whether a particular patient is a disease, whether the person has a disease or not, right? So we don't have in the world of machine learning, we are just giving some examples and let the algorithm to make a model so that it can make future predictions based on the data, right? So in the artificial intelligence, basically there are two systems where one is based on the hard coded logic, where we need some expert uh, consultation, and the other one is machine learning where we don't need much uh, uh, assistance from the expertise, but we have some clue about the relevant information, the relevant fields of data, and then we ask the algorithm to decide how to identify how to do some classification or regression. That means how to solve the problem using this information when the model is given new information, right? So that is the difference between the other AI models and the machine learning based AI model. So the machine learning is a form of AI, and the machine learning is different from the rest of the AI because uh, in the machine learning it is mainly based on data, and the data is created in the model. The model would decide whether this is a uh, this person has dengue or whether this person is not, right? So deep learning are a form of is a type of machine learning that we are not going to cover in this uh, subject module. So we will be discussing it the, in the future module, right? So so from now on, we are going to discuss about machine learning. So in order to learn the machine learning, we have to learn about uh, the fundamentals of the machine learning using statistics. That is why we are learning statistical and machine learning. Right? So if we summarize what we have learned up to now, the intelligence is understanding the nature or generate useful information or make predictions from the data. Right? The artificial intelligence is mimicking the intelligence that was already there, that can be already observed in humans and animals by human-made machines or basically computers, right? So at the moment, the computers are the machines that are uh, bringing the AI into the table, on the table, right? So machine learning is a form of AI where it is consuming the data which we have given and achieve the intelligence. So in the machine learning, we give a lot of data. The model would learn from the data, and the model would be intelligent. Model would build an intelligence for that type of data, and the model can make future predictions or it can achieve AI. So when I say AI, don't expect too much, right? So AI is not about human-like intelligence, right? So that is what we have to learn, right? So in the beginning we said that even thermostat is a form of AI, right? So actually we are not learning this that much low level of AI, but we are learning about some AI which we can achieve with ML, which we can do some useful jobs, right? So like where we can classify diseases, whether we can diagnose diseases, whether we can take business decisions, when we can take even life decisions, right? All of this stuff we can use machine learning, and that is what we are going to learn. Deep learning is a form of machine learning algorithm. We are using many or multiple, one or multiple layers of artificial neural networks for making machine learning models. So those are when we have multiple uh, neural networks, multiple layers of neural networks, when that is known as deep neural networks. And when you are using deep neural networks for machine learning, we call it as deep learning, right? So we are not going to cover the deep learning in this lesson, but we are covering the machine learning and how it is achieved, uh, and how it is uh, how the machine learning is achieved with the principles of statistics. So now we can again compare what are the things that were there in the AI, right? So in AI, it can be expert systems, control systems using control theory, and there can be computer-based algorithms, and obviously there can be machine learning systems. And when the AI is developed by fixed set of rules or using some expert intelligence, we don't call it we can call it AI, but it is not a machine learning, right? The machine learning is when uh, a person with less domain knowledge get some data, and they are using the machine learning algorithms to train with those data, and they come up with machine learning models so that they can use the machine learning models to make the predictions or take the decisions based on the data. So some of you might have seen the famous memes where when you take the cloth, when you take the cover of the face off in the cartoon Scooby Doo, right? Of saying that it is which is ML machine learning. When the cover is removed, in the inside it is a set of if-else statements. So, but that is not true, right? So this is not the truth. This is a misconception, right? So, and if you can achieve AI with if-else statements, but if you use if-else statements, that is a it can be an expert system or it can be an algorithm or something we can call it, right? But obviously it is not a machine learning system. So in machine learning systems we don't have explicit if-else statements to for the logic, right? So we may have if-else statements for the other stuff like for taking to read while reading the files and so on, but for the for the logic of taking decisions, we don't have if-else statements for in machine learning systems, right? So what we do is we take the data, and then we train the model, and then we using the model, then we test the model whether it is working, and then we are taking the model to the production, and we take decisions, right? So that is the main difference between uh, and the rest of AI systems and machine learning systems when it comes to machine learning, right? So you have to understand that the machine learning system is solely based on data and algorithms, but not based you, and you don't have to have any uh, right have any domain expertise. The domain expertise can be helpful, right? So I don't say the domain expertise is not necessary, because using domain expertise you can find the data that are highly relevant, right? So and then you can pre-process the data and tune the machine learning model so that the model will get higher accuracy, right? So that is obviously an advantage, but the idea of the rest of AI models are about uh, writing some logic to come up with uh, data using the logic. But when it comes to machine learning models, we don't use that. We just tune the model when we tune the algorithm, and then we give the data, and it would automatically get learned, and now the model can make predictions, take decisions with new data, right? So that is a machine learning system. So what is statistical learning? In order to achieve machine learning, right? So we say that machine learning is learning with the machine. What is the machine? Generally, the computer that we use day to day is the machine. There are some special purpose computers designed for machine learning, right? So we will go to that level. We will not go to that level in this lesson, but generally, the computer is the machine, right? So how do computers come up with these decisions? So they are based on statistical principles, right? So how we come up with the intelligence is actually a problem with statistics. But don't get don't misinterpret it as deducing the machine learning into statistics, right? So there is a very big difference, right? In the statistics, you can learn, right? So there's a subject called known as statistical learning, where you can use statistical models to learn, right? So in the earlier age of machine learning, it was mainly statistical learning, where we have sound solid mathematical background with statistics, and when you have data, and then you make statistical models, and then you can come up with the statistical model to come up with predictions or decisions. But later, those models got improved more and more, and then the interpretability or the mathematical rigor was kind of forgotten. That means the scientists became more pragmatic. Pragmatic means they wanted more practical results more than focusing on proving the models mathematically. Right? So they tried to, so they built models more and more without explicitly understanding each and every aspect of math- mathematics and statistics. Right? So, so what really happened was the statistical learning was when it was advancing in the field of machine learning, the statistical background was kind of blurred. That means it was not really understood yet correctly by humans. Mm, So it's not understood correctly well by humans doesn't mean that there's no statistical background. There should be, right? But it is not. So the humans have not make developed the science and technology to interpret the machine learning models when they got developed. So the development of statistical models to interpret the machine learning models was later mm, reduced and was practically biased to make much more practically important models to make uh, higher accuracy decisions based on more data, right? So people were making models uh, again and again without that much focusing about uh, proving the uh, proving the proving its inner statistical calculations with mathematics, right? So in the earlier forms of machine learning models can be highly interpretable with statistical learning. And in this lesson, we are mainly learning about these kind of models where we have some form of statistical background, so that we can later move into much advanced models that are much more. We are not in those models. We are not going to focus about statistical background, but we are going to focus about their pragmatic usage, why they are using it, when we are going to use these models, and how we are going to use them to achieve our objectives of our business domain or our use case, right? So other than trying to map them into the statistical fundamentals and prove them, right? So don't expect that we would do a lot of statistics in this subject when we are going ahead, right? So in the earlier times we will be having the statistical fundamentals, that but we are not going that much detail into statistics, because when the models are getting much more advanced, its statistical models are getting maybe getting exponentially complex. So it's not practical to understand and interpret all those statistics, but we have to uh, depend on the empirical evidence. That means we measure the accuracy of these models, and if the accuracy is high, or the we call it as performance, uh, right? In the performance, its accuracy is one of the performance metrics. So if the performance is good, we take it as a good machine learning model. So we don't uh, try to prove it with statistics, but we keep improving these machine learning models even when we lose the touch of statistics, right? Statistical model learning, we have a higher mathematical background, and they can be proved with statistics and mathematics clearly, so that then you can see how it's working inside using the mathematical knowledge. So if you compare the statistical learning and machine learning, uh, this one I have taken generated from an AI, right? So here you can see the focus, foundation, the assumptions, and interpretability of statistical learning, right? So the idea of statistical learning is to understand, right? So to make inferences, and so that people can identify how it is working and so on. The idea of machine learning is basically to uh, for achieving something, right? So to achieve our goal, uh, more than interpreting, right? The statistical learning is mostly based on the foundations of thorough uh, statistical techniques, uh, which are proven uh, consistently. That means with clear mathematical background. But the machine learning is based on empirical data, like accuracies, precisions, and recalls. Which we will be discussing later, right? Uh, and when it comes to statistical learning, in some cases, most of the cases, we have to be based on we have to take the assumptions of the data distributions when we are using the statistical learning to make the predictions, like the norm. For example, the data distributions would be a normal distribution and so on. But when it comes to machine learning, we don't that much think about the distribution of the data. We don't assume about the distribution. Generally, uh, what we want with machine learning is to give any type of data and get higher, better results, right? And statistical learning is much more interpretable than machine learning, right? The machine learning is much more about having better results, having higher accuracy or higher performance than statistical learning, right? So actually, machine learning was born with statistical learning, and it was evolved uh, with more models and more than statistical learning. And both of them are important, but when it comes to uh, the real world data, where it is difficult to put them into uh, where we can't map them into certain distributions like normal distributions and so on, then we can easily use machine learning models to make decisions. So that is why the machine learning is very popular these days. So moving up with the uh, this course, right? So we will be more focused about the machine learning, right? Where you should have the understanding about the machine learning from very basics to the highest level that is taught in uh, the universities throughout the world, right? And if possible, we would try to give you some understanding about the machine learning life cycles, how these models are developed and set into production. But the main idea is that you would learn about the how these things are designed and how it is when to how to use and when to use these models, and how to tune these models, and how to prepare the data for these models, and how to interpret these models, how to evaluate these models, how to find what are the how these errors accuracies are to be benchmarked and evaluated, right? So that is the main purpose about this course. So we will uh, come up with the statistical background, but we will not go much deeper into the statistics. One reason is that we may not be that much having a heavy statistical background, and the second thing is that we have to cover a lot of machine learning related stuff, which is much more practically significant, where we have to use our intuition to use statistics, right? So when in the practical world, we are not that much going in much detail into statistical learning. When we have enough data, we use the machine learning models to, and we develop the machine learning models with trial and error and come up with better models. So, but if you have good understanding about statistics, then you can do these things much faster and come up with better machine learning models or statistical learning models better if you have a better understanding about the statistics, right? And this is mainly based on intuition, and uh, it is taught in statistics, statistical fundamentals basically, right? So, uh, so we for the assignments also may be given some uh, machine learning projects, so that you can learn about machine learning theories. So for the references, I have not added a book for the machine learning. So I have added this specialization course in Coursera, where you can do it for yourself. If you want to get the certificate, you can ask for the what you call this mm, financial aid. And this course has the some of the best machine learning models that to date that are using in practice, and there are more uh, models that we are there may be several more models that we are maybe covering in this lesson, but this lesson is this specialization is a very good one if you can do it, right? So it is a beginners level course, and it is taught by with the collaboration of deep learning.ai and Stanford University. And there's if you want to learn about statistical learning, you can use this book. It is there in the statlearning.com. It's a free book where you can learn it with Python code, right? And in order to learn this subject, uh, I hope now you already know about the Python fundamentals, basic Python programming, and so on. And within this week and so on, I hope you guys uh, learn some uh, the remaining Python stuff and the libraries of NumPy, Pandas, at least, right? So Scikit-learn would also be useful in the future lessons. But the NumPy and Pandas, which are two libraries in Python, right? So the libraries are two modules that are packed, right? So you can import a library and then you can use what is there in the, the interfaces that are there in the library to write code, right? So in order to, for example, if you want to use some machine learning model known as linear regression, you don't have to write the linear regression algorithm by yourself, but you can use a linear regression algorithm available in, for example, scikit-learn library, and then you can use it easily, right? Uh, in order to process data, to remove unnecessary data and to pre-process the data, you can use NumPy and Pandas. Those are also libraries, NumPy, Pandas, scikit-learn. Those are the libraries that you have to learn, right? So if after this lesson, I hope you guys uh, go to the internet and do some basic tutorials about these few libraries, because those libraries will be used throughout the machine learning career, right? Uh, and then you don't have to worry that much about the problems that you get with machine learning. So you may find that even your friends may not be familiar with machine learning and so on, but don't worry, right? So because you have ChatGPT, you have Bart and many other AI tools along with the Google, right? So in the earlier times, we ask people to use Google, but these days you don't have to uh, waste your time in Google. You can simply ask the ChatGPT to generate a code, right? So if you want to write the code for a specific task using a certain library, or even without telling the library, you can just ask the ChatGPT to write the code with Python. Even if you don't ask it to write with Python, it would write it with Python, right? So because most of the machine learning is written in Python, right? So if you ask it to specifically run whatever in your specific use case, it would write the code. What you have to know about what is happening inside and what is the algorithm that you should use, how it should be used, what are the data that you are going to deal with, what is the nature of the data, and so on, right? So when you know all these things, you can get the help from ChatGPT and learn it. So even if you have these problems, if you have some ambiguities with these kind of problems, and how should I process this data? I have these problems with this data. What should I do with this? You can get the help of ChatGPT and so on. So they can actually get you the information very quickly in your fingertips. You don't have to waste time, right? If you have any other questions, you can ask me or some other. Uh, you can ask for use forums, or you can use some other human being to ask questions. But the easiest way is getting the help from ChatGPT. Right? Some of the ChatGPT content may be incorrect, but these days that is very accurate, right? But some of in the earlier batches, some of you have used ChatGPT for answering the exams, and they got into trouble, right? So don't ever use ChatGPT for answering quizzes or exams in the in this course, right? So unless it is asked, right? So but in future, right? So the when everything we learn today may be done with AI. So in that case, it is okay to use AI to write everything. So the basic idea is that you would have to learn how to use AI, not to write AI, but in this course, we are going to learn how the AI works. So in order to learn how the AI works, you have to do it yourself, right? So you have to know how to do it, right? So once you know it, you can get the help from ChatGPT in your career or in your business or whatever. But for the exams, you have, if it is not asked to use ChatGPT, you can't use it, right? Okay. So let's move what we are expecting from machine learning, right? So here we are going in a case what we are going to do, right? So in machine learning, what we are going to do? So say we have some data, right? So we may have some data in our database, in our Excel sheet or our CSV file. So if you don't know about CSV file, just forget it, right? So you have some data, right, in Excel sheet or some file or some database or wherever, right? Now, in the machine learning, what we are going to do is we are going to uh, learn a model, and then you want to get the insight of that data, right? So how we are going to learn a model is we are going to train the model with this data, right? So the idea is that we are going to use this data to train the model. Train the model is not there, right? So we are going to train this data with a certain machine learning algorithm, right? So then then what is there would be called a model, right? So once the model is built, we are going to use that model to predict or make inferences or take decisions, right? So all the three are same, right? So once we have data, we select with our intuition, with our knowledge, we find the best machine learning algorithm with the hyperparameters, so or the tuning factors, right? So the tuning parameters, in simple terms, we learn a model, and learn a model means we create a model using the data, and then what we want is then we use that particular model to make decisions, in simple terms, right? That is known as making inferences or predicting, right? So we hope to do it with new data, right? So then not the data that we are given in the data set, right? So our idea is that we are given a data set, and we are going to train a model. We are going to create a model so that when we are given new data, which are not seen up to now, then even with new data, it can make predictions with a high accuracy, right? So the process of creating the model is known as training, right? So how do we know uh, once you train the model, when you create the model, that the model is accurate enough? Right? So I mean, you are given a data set in the Excel sheet or somewhere, right? And then you use a particular algorithm, and then you create a model known as training a model, right? And once you train the model, you want to make sure the model is working correctly for unseen data. That means the model is working for the data that are not there in the this given data set. So how do we do it? So what we have to do is we have to test the data with uh, a separate data set to find the accuracy of the model. So what we generally do is when we get the set of data, uh, we divide the data set into two partitions, as the training data set and the testing data set. And then we train with the training data set, which is the majority data set, and then we test with or we make predictions with the test data set, and we find how accurate the results are given for the test data set. If the accuracy is not enough, then we have to look back, right? So whether we have collected the correct data, whether our data is accurate enough, are there any high level of noise, Are they relevant? Are they to are they relevant? Are they from the correct distribution? Or whether our machine learning model is correct, whether you have used the correct feature set, or whether our hyperparameters are correct, or whether we have to train more. You have to think about all these things again and do the same thing again and train another model and test with the test data set and check the accuracy. If the test is passed, we take the model, train with the data set of data, and then we test with another unseen data set, which is not used for training. And then we try to see whether how much it is accurate. If the accuracy is past a certain level, like 80% or 90% or something, whatever we have already set, then we pass the test and then we can use that model in production, or we can use it for making predictions for unseen data, right? This is what we do, right? There are two types of machine learning models, mainly, right? One is known as supervised machine learning, and the other one is known as unsupervised machine learning, right? If if the if we find if it is a supervised machine learning problem, so we will tell what is the difference later, right? If it is supervised machine learning problem, this is what we do. We have, if it is a supervised machine learning data set, you should have y variables, right? So what are y variables? In the data set, there are two types of variables. One is known as x variables, the other one is known as y variables. So what are x variables? Those are also known as independent variables, right? When you draw a graph, so what comes in the x-axis, which are independent variables, right? What's there in the y-axis? It is known as the dependent variables. Right? So what we are going to do with supervised machine learning is, with supervised machine learning, we are going to predict the y values for the given x values. In the 2D graph, you can see only one x value and one y1 value, right? But when it comes to multidimensional graph, you can have multiple x values and it can be a y value, right? So it can be multiple y values as well, right? So in general, it may be a single y value, right? So the x values are known as independent variables and the y values are known as dependent variables. In the supervised machine learning, we in our data set, we have both x values and y values. In the data set, if it is given an Excel sheet, we have columns for x1, x2, x3 for x values, and we have the value for y. We have the y labels as well. So for each of the x values, if we have y values, the y value is known as the label, right? For each x values, what has happened? What is the prediction? You have the label, right? So you should have the past data in order to train a supervised machine learning model. So in the supervised machine learning, what we are going to do is we are going to train a model based on the label data, right? In the unsupervised machine learning, we don't have y values. That means we don't have label data. That means in our data set, we only have x variables, x1, x2, x3, and so on, but no y values. So now which type of data sets are much expensive? Either labeled data sets or unlabeled data sets. Labeled data sets, right? Because in order to get the labeled data sets, you should have past experience, or someone has to manually label it or something like that, right? Because you have to have the y values, but when you only have x values, that doesn't mean anything, right? So you can have a lot of x values, and if you want to do some inference, you have to move the data into clusters and so on. That is known as a unsupervised machine learning problem. Right? Supervised means always remember that we should have labeled data or y values, y values in the training data sets. In unsupervised machine learning, in the data set, you don't have any y values or the dependent variables. So that is the first thing, right? So looking at the data set, you can identify whether what you are going to do, right? And then we select a suitable machine learning algorithm. If it is a linear, if it is a supervised machine learning, maybe you can use a machine learning algorithm like linear regression, right? So in the future lessons, we will discuss how we are selecting a machine learning model. So then what we do is we, as I said earlier, we partition the data set into two. The majority of data set is taken as the training data set. So like 70% or 80% of the total data is taken for this partition, which is the training data set. The remaining data is taken for the testing purpose. That is known as the test data set. So in the case, if you have partitioned, if you have taken 80% of data for the training data set, you can take the remaining 20% data for the testing data set. And then you train the model with the 80% training data set. And then you test with the testing data, the 20% testing data sets. And if the accuracy or the or other performance parameter, what we want is higher, right? That means when the tests are passing or the model is accurate enough, then we can use that trained model for making more predictions or making more decisions for unseen data, right? It's unlabeled data. So if it is a machine learning problem, you can make regression or classification. You can do regression classification tasks for unseen data. And if it is an unsupervised machine learning problem, you can make inferences for, like make clusters for example, making clusters for new data. So that is the difference between supervised and unsupervised machine learning when it comes to testing. If the testing phase has not passed, we have to start from the beginning. You have to look at the data, and then you have to look at the algorithm, whether we have selected the correct one, and then we divide it into two, and then we test it again, train it again, and test it again, and you have to test the accuracy again, right? And then you have to continue this process again and again until you come up with a model that is accurate enough for your requirement. Right? Say you want to diagnose a particular disease with an accuracy of 90%, then you have to make the model accurate at least 90% with its predictions, right? Otherwise, you have to continue. You will have to try with different data sets, more data, different sampling techniques, more randomized data collection techniques, and then you have to use better machine learning algorithms, and so on, until you come up with the required accuracy level. Right? This is an example of supervised machine learning. So in this case, there are two types of variables as we discussed earlier. Right? The one is known as the independent variables or the x values or independent variables, x values. We sometimes call as features. In statistical machine learning, we call it as predictors. So the other type of variables known as y values are known as dependent variables or target variables or response variables. Right? For this particular example, I have taken a very small data set, but in real world, we can't use this much smaller data set for making predictions, right? So these are because they are not accurate at all. But for this demonstration, I have taken a very small data set. This data set is actually I have added by just imagination. This is not an accurate data set, right? So I just taken some random data and for you to explain the concept, right? This has nothing to do with a real data set, right? So here what we have taken for this example is a set of data where you can have have three x variables and y and a one y variable. Right? So the three x variables are, the first one is the GPA of the person. The second x value is the income of this person. The third x value is the IQ of this person. And what we are going to predict with this model is the life expectancy of that person. Right? It means how the person what is the, depending on the GPA he has got in his degree and the income he has achieved, and with the IQ level he has, how much he would live, what is his life expectancy. So this is not a real model, right? So I have just given this for example, right? So first thing is, because we have 4 data points in this data set, we can take the first 3 data set for training and testing. So the idea of the last data set is, last data point is, we have to predict the last row, right? So that means with these 3 data points, we have to train and test the model with first 3 data set, first 3 data points, and with these x values 3.56, 4,800 and 112, we have to predict the life expectancy. This is the prediction that we have to make, right? So with these 3 data points, we have to do it. So actually, in practical world, we need hundreds or thousands or millions of data points for training and testing, right? So 3 data points are not enough at all, right? So this is just a demonstration, right? So I have used the first 2 data points for training because the higher proportion of data has to be used for training. Because we have labeled data, right? We have x values and the y label, x values and the label. Because we have labeled data, you can use supervised machine learning and train the model. This is the first thing we have to do, training the model. The second thing is, we have the model, we have to test with the remaining test data set, which is where we use the third data point, which is this data point. We use it for testing, and with this testing data set, where there is only one data point, we are using it for testing this developed machine learning model. And because we have got accuracy of 80%, right? What we do is we get successful with the machine learning model's accuracy, right? So suppose now we have got our benchmark was to have at least 75% of accuracy. Now we have got 80, right? So now we can predict the life expectancy when the GPA is 3.56 and the income level is 4,800 USD and the IQ level is 112. Then you can predict the life expectancy. So the third phase, using the trained model, right? This machine learning model is used for testing, and if because it has passed, we are using the same machine learning model for making predictions. The first we did the training, then we did the testing. The testing has passed with the required accuracy level. Because of that, now we can use this machine learning model for predicting or making decisions on with new data. We give these three x values as the x variables or the independent variables for this machine learning model, and then we can generate the new expected life expectancy is 76. Right? So that is the purpose of this machine learning model, is to predict the life expectancy. Right? So this number of data points are not sufficient, as I have mentioned several times, right? So you should need, instead for training, you may need maybe several thousands of data points. And for testing also, you may need at least several hundreds. And so those things also depends on the number of data, the quality of the data you have, and the noise of data you have, and many factors, right? And then you can, once you have achieved a sufficient level of accuracy, you can make predictions for new data points. That is the purpose of supervised machine learning. So now let's move into much mathematical notations of statistical machine learning. Yeah, this x1, x2, x3 are the independent variables. Y is the dependent variable, right? So then the relationship between x1, x3, x3, x1, x2, x3 to y can be mapped with the function f, right? So in this case, we can write y as a function of x1, x2, and x3. Or in simple terms, we can say it as y equals fx. 1, removing 1, 2, and 3. So there can be multiple x variables like n variables. So you can define the y variable as a function of fx, right? So you might have learned this in your high school. This is the function from x to y. But as I mentioned earlier, this machine learning model is not representing the exact function, right? It is and it is just an approximator to this function f, right? So although we call it this as a function, when you get this x1, x2, x3, we can't exactly predict the y variable. We can get the approximated value to this y variable. That is what they are doing in machine learning, right? So this f is not the, so what we are going to do with machine learning is we are going to find the approximation function for f. So with machine learning, because obviously we can't find the exact f, right? The reason is that there can be some errors and there are some inherent uh, deficiencies in these x variables. Not all the information can be captured with x variables, and there are some inherent problems with the algorithms. Because of that, we can't achieve 100% accuracy. So you can't predict the exact f function. But with machine learning, what we are going to do is we are going to find the approximation function f hat for f, right? So instead of finding f, what we are going to find with machine learning is we are going to find the f hat, which is an estimator for f in statistical terms. we are going to find an estimated one, which is known as the estimator for f, which is known as the f hat, right? So when you give the x1, x2, and x3 for this f hat variable, we get the estimator for not the exact y, but the estimator for the y, which is y hat, right? So this y hat is also a estimator for y, not the exact y, because once we give the exact x1, x1, x2, x3 for the estimated function f hat, you don't get the exact y, right? So you get the estimated y value, which is the which is which we denote it as y hat, because now this y hat is not equal to y. Right? There is some error. This error is represented by this epsilon. Right? So here what we are learning is the uh, notations of machine learning. Right? So the trained model will be f hat x. The f hat x will be y hat, which should be equal to fx plus epsilon, right? Because fx is y, right? Fx is exact y, and but when the error is added, the exact y would be given, right? And sorry, fx is y, and the epsilon is added. That means that when the error is added, the estimated model function f hat x is given, which is also equal to the y hat, right? Or the or the estimated dependent variable, right? So this is an approximated model function, and this is the predicted value from the machine learning model. So this is the approximated function with the model. So the model represents this f hat x, and then when you give this x values for this model, f hat x models, it would produce a to predict the y hat values, not the y values, which is a approximated value for y values with an error of epsilon. So epsilon is known as the model's error for the given x value. Right. So that is enough for the mathematical notation, right? So now let's learn about the two types of supervised machine learning models. Right? So earlier we said that there are two types of machine learning. One is supervised machine learning, and the other one is unsupervised machine learning. The supervised machine learning, we have labeled data. In the unsupervised machine learning, we don't have labeled data. That means we only have x variables, right? In supervised machine learning, we have x variables and y variables. In supervised machine learning, now we say now there are two types of supervised machine learning problems. One is known as regression problem, and the other one is known as classification problems. Right? The regression problem is when the y variable is continuous. Right? So if the y is a continuous number, such as temperature, length is known as a regression problem. Right? So that means the value that we have to predict or estimate is a continuous number, continuous value. It is known as a regression problem. Right? So for example, if you have some if you have certain chemicals and in certain proportions, and if you want when they are mixed, what is the temperature of this mixture? So that is a regression problem. Right? Or if we want to, if we are given some information of a potential customer, And if you want to find whether this potential customer would buy this product or not, in this case, the Y is a discrete finite number, right? So whether he buy or not is a binary number, right? Or such as gender, country, right? If he's buy or not, this is a binary value. So then that is known as a classification problem. If the Y value is a continuous value, it is known as a regression problem. If Y value is a if it is Y value is a discrete finite number, it is known as a classification problem. So why do we call finite number? Because Y can have infinite values as well, right? So for example, the term we can have some values up to infinite, but in a practical machine learning model, we can't learn infinite number of infinite Y values and do the classification, right? So we should have finite fixed few number of classes for classification in order to develop a classification model, right? So when we have finite few number of classes, discrete classes, like gender, whether this model is predicting a female or male, or depending on the income level, skin color, and all those things, we can predict the country he is from. The country is a discrete value, right? And there are only 200 number of several 200 cells. I don't know how many countries are there. There are only fixed number of countries, right? So if we want to predict the country, it is a classification problem. In all the times, X is a independent variable, right? So don't forget it. So now let's first move into this supervised machine learning problem. So now first read this lesson, right? A real estate company wants to estimate the sales price of a house given the following details of last houses sold as data with parameters including the sales price. So the real estate company wants to estimate the sales price. So this should be the Y value, right? So Y value is the sales price. Price, what is it? It's a discrete value or a continuous value. It should be what? It should be the price is generally it, it's discrete if you think it has sense, but it is a continuous value, right? The price, if it is a price class, it would be you can consider it as a classification problem, but when it comes to price, it is a continuous value, right? And the house given the following details: 100 details of last houses sold as data with parameters including the sales price. So the sales price is also given. That means the Y variable is also given. If the Y variable is also given, that means it is a supervised learning problem, right? Because the Y variable is a continuous value, it should be a regression supervised learning problem, right? So let's just look at the X variables. These are the X variables: area of the house, area of the land, number of rooms, number of floors, distance from the main road. These are the X variables, right? So the sales price is the Y variable. So when you are given the past data, those are the data. This is the data set, right? So you can take a proportion of it, like say like 80% of data for 80 data points for training and 20 data points for testing, right? But 100 number of houses, we don't know whether they are enough or not, right? So that depends on the data set. So this is a supervised learning problem with price as the Y parameter and the parameters given as X parameters. So now take this example, right? The problem is a doctor wants to diagnose a cancer as malignant or benign So the malignant means there's a cancer, right? Benign means it is a innocent tumor, right? The doctor wants to diagnose a cancer as malignant or benign using the data of 5 tumors with labeled data. So you have labeled data, so it should be it may be a supervised learning problem, right? Uh, because in unsupervised data for so with labeled data you can do the unsupervised as well, right? So don't forget, right? So with labeled data you can do unsupervised training as well, but for the supervised learning you must have labeled data. That is the idea, right? So when you have a labeled uh, label, that doesn't mean uh, you can't use unsupervised. You can, but for the supervised machine learning you must need a label. Why label, right? So the label data are length of the tumor, age of the patient, having a cancer patient in family, the family history, right? So this should be like maybe like a Boolean value, right? So the age is a uh, maybe a number, right? Length of the tumor may also be a number. So because it has label data, it should be a maybe a superstanding problem. And because he's trying to find build the model to decide whether it's malignant or benign, that means there are two classes, discrete classes, either malignant or benign. There are two classes or categories, right? So it is a classification problem, right? With two classes. So this is a classification supervised learning problem, right? Because there are two variables, it is known as a Boolean X variable. So sorry, this this having cancer patient is a family is a Boolean X variable, right? So age is a float type, length of the tumor and the age of the patient are float types. The cancer patient in the family is a Boolean value. The third one is a Boolean value, right? The Y value, supervised classification problem, where malignant or benign nature is the Boolean. Is Boolean Y parameter. The other parameters of the given data are X parameters. So these are X parameters, and diagnosing whether it's a cancer or not, benign or malignant, is a Boolean value, right? So the Y value is a Boolean value. These two are float values, and this one is a Boolean value. These are the X values, and this is the diagnosis is the Y value or the dependent value. Right? So now let's move into the unsupervised machine learning. So as I said earlier, in the unsupervised machine learning, there are only one type of feed that is required, right? So it, type of data can be either called as fields, variables, or parameters, right? So general parameters we don't call it as parameters. Parameters are called for the models inside parameters, right? So generally this term is not used, right? Fields and variables. Variables are sometimes variables are also called for the inside variables, the models inside variables, right? So, but in this case, what we are calling is X variables, right? The input variables or the fields. So there are only one type of uh, input variables, which are X variables, and no dependent variables or Y variables. There are only independent variables or X variables or features, right? So with X variables, you can't do much with X variables because you don't know what exactly the Y values or the predicted value, but you can do some inferences with X variables. Right? So these are some of the examples for unsupervised machine learning, like clustering. Right? So you can, by looking at the X variables, you can cluster the data into a pre-defined number of clusters, right? Or you can cluster it until certain threshold is met, right? Like we divide the data into two most distant data points, and then divide the divide it again and again until a certain thing is met and so on. And then we can come up with a set of clusters, right? So of data, because we don't know the y value, we can have these kind of inferences with x variable, right? And then we can use two-dimensional reduction, right? So when we have a lot of x variables, uh, for especially for as input variables for a machine learning model, you may find that some of the variables are not significant. That means that they are not relevant. In order to reduce the number of x variables, that means in order to concentrate the information, you can reduce the number of dimensions of this x variable. For example, if there were 3x variables at the beginning, now we want to reduce it to 2x variables. So you can do the dimensional reduction technique. So one is known as the principal component analysis, and you can take only the first two principal components as two dimensions. The idea of dimensional reduction is you can reduce the number of features, number of input independent variables to a fewer number to reduce the noise, right? When you have high number of x variables, there's a problem known as case of dimensionality. We may be discussing it later. Right? In order to do that, we have to reduce the dimension. So that is also an unsupervised machine learning problem. And when you have a set of x variables, you can find the relationships between the common relationships between x variables, right? And using these common relationships in between x variables, that means how the x1 is related to x2 and x2 is related to x3 and x3 is related to x1 and so on, we can have some relationship. And with these common relationships, we can find some of the data points that are not normal, right? That is not in order to find these abnormal data points, you can use this unsupervised machine learning, which is known as anomaly detection. So even without any y variables, just by looking at the x variables, some machine learning models can identify the unusual data points or abnormal data points, which is known as which is the task of machine learning known as anomaly detection. So because we can do it without any y variables or the dependent variables, we call it as an unsupervised machine learning, right? So these are not the only unsupervised machine learning techniques, but there can be many. There are many, but these are some of them, right? So this is an example for unsupervised machine learning, right? Where a website owner, right? So this is an example of a online sales website where a website owner wants to categorize. So the visitors are coming to your website, something like eBay or Alibaba, right? So suppose you are the owner of that website. So different people are visiting your website, and with your website you can extract some information, right? From each of the visitor, and you can uh, classify each of the what your idea is to uh, categorize. The web owner wants to categorize its past 1,000 visitors into 10 types based on the following data. So he doesn't have any y value, right? So what he only have is are these data points, data fields, which is the visited hours of the day. How many hours the that particular user has visited that particular site. Not how many hours visited hour, that means whether he has visited in 6 o'clock, 4 o'clock, or so on. And the visit time, how long he has stayed in this website. The most preferred product, so the product may be given a number, and you can find or it can be represented in some other way, right? So you can find each of the number, and you can find the web browser use, right? So web browser is also a category, right? It can be Firefox, Google Chrome, and so on. And the country of the IP address, so you can find the visitor's IP address, and from the IP address you can find the country, right? Using another service. So with this data, the owner wants to cluster these visitors into 10 types. So he has decided I want 10 types, right? So how does he know he wants 10 types? Actually, he doesn't know, right? So initially he may have tried to do it 10 times, 10 types, and maybe after he get the results, he may change the types until he get a higher and you get a better goodness of fit. So we will learn these theories later in our future lessons, right? So this problem, because there are non-labeled data or 5 parameters, this is an unsupervised learning problem. Because he wants to cluster, it's a clustering problem. The given parameters of the given data set are x parameters. So these are x parameters, x variables, and we can use a k-means clustering or some similar clustering algorithm to cluster the x parameters into 10 classes. So k-means cluster is not the only clustering algorithm that you can use, but you can use a similar clustering algorithm. This is how the unsupervised machine learning. So this is all for the today's lesson. If you have any questions, you can ask.